Here there is a question, and to solve this one we use a relation, and I write that relation. U t to the power n is isomorphic to z p to the power n minus p to the power n minus 1, where p is an odd prime and n is a natural number. Okay, so we can take p equals to 37. 37 is an odd prime and n equals to 1, and if I place these two values in this, then we have u 37 isomorphic to z 36. Okay, so the last written relation is most important for this question, so I erase the remaining parts. Okay, I will be using this relation for all the options, A, whether it be A, B, C or D. So now I go for A, option A. And what does this relation mean? This relation means that these two groups have same characteristics. Okay, but there is one difference. You have to keep that in mind. The difference is the group operation of U37 is multiplication, but the group operation of Z36 is the addition. So what is written in option A? First I modify option A. Okay, here I modify Z bar member of U37, this is same, and after that you see the equation. In that equation I multiply G bar both sides, then this will be G bar square equals to 1. 1 is the identity element of U37, and equivalently this can be written, since you see here U37 is isomorphic to Z36, so the same can be written as G bar member of Z36. Since the group operation of Z36 is plus, so G bar square can be equivalently written as 2G bar. Okay, 2G bar means G bar plus G bar, since the group operation of Z36 is plus. So this should be 0, the identity element, and 0 is the identity element of Z36. So we have to find those elements of Z36 whose addition with itself gives you 0, and when you go to find, then you will have only 2 elements, and those elements I write in red. Those elements will be the identity element itself. You add 0 plus 0, then you will get 0, and the second will be 18. You add 18 by itself, that is 18 plus 18, then this will be 36, and mod 36 is 0, so this will give you 0, and you will not get any more elements in this group. There are only 2 elements, these 2 elements. So our option, the statement in A, not the option, the statement in A is correct. So I here take this tick mark, but you know we have to choose the false one. You see here. So this option should not be marked in the examination, because you see this is a correct statement. Now I go for option B. For that I erase this thing. These are done. Okay. These things. Okay. We use the same relation for option B, and here I type the statement in option B equivalently, and that will be the order of the element 10 bar, since U37 is isomorphic to Z36, so I place at the place of U37 I write Z36 is 36, and we have to check this blue statement. Okay, this blue statement is equivalent to the statement given in option B. So what does it mean? It means that suppose this statement is true. Okay, so it means that order of 10 bar equals to order of the group Z36. It means that when this happens only when Z10 bar is a generator, but for what does it mean? It means that if you add 10 36 times, only then you will get 0. This is not correct. Think why. If you add 36 times, before that you can get 0. Suppose you add 10 plus 10, you will get 20. In this way, if you are adding 10 by itself, 10 plus 10, thereafter 10 plus 10 plus 10, then 18 times, if you take 10 18 times, then this becomes 180, and mod 36 mod 180 is 0. It means that order of 10 is 18, not 36. Okay, if you add 18 times, then you are getting 0. And so this option is not correct. This option is false. And there is one more way to say the same thing. Here, assuming the order of 10 to be 36, we arrived at a conclusion that 10 bar is a generator, and to be the generator, the GCD of 10 and 36 should be 1, but the GCD of 10 and 36 is 2, not 1. So from this viewpoint also our option is wrong. So this option should be marked in the examination, because we have to choose the false one. Okay, so the same thing can be said in two ways. I mentioned those two ways. So if you are in the examination hall, then we are done. We have got the option to be marked. But here we are not in the examination. We are here to learn something. So we should go for C and D. And we should check why those two options are also correct options. So I again erase the remaining except the relation. Okay, I have erased except the relation. Now I again use the same relation. You see, there is a homomorphism. We have to check the homomorphism from U37 to Z plus. Okay. So to check that, from this relation, U37 is a cyclic group. Not a cyclic group, but also it is finite. So we can say that U37 is a finite cyclic group. So its image, that is phi U37. Suppose the homomorphism is phi. So phi U37 must be cyclic finite order. What does it mean? It means that we have to find a finite cyclic group in this Z plus, and there is only one finite cyclic group in Z plus, and that subgroup is the subgroup containing the identity element. This subgroup, 0 is the identity element of Z plus, the set of integers. So there is only one subgroup. So exactly there is one homomorphism. Okay, so this statement is correct. So since we have to choose the false one, so this option should not be marked in the examination hall. Now I again erase the whole thing except the relation, and the same argument which I discussed for the option C, the same can be used for option D. What was in option C? In option C was we have to search for a cyclic group of finite order in this Q plus. Q plus means the set of rational numbers, and in that group also there is only one finite cyclic group, and that cyclic group is this group, the group containing the identity element. So this statement that there is only exactly one group homomorphism is correct. Since the statement is correct, so this option should not be taken to mark in the examination hall. So okay,